gracias por asistir. Tenemos hoy el placer de tener a varios
Another
delegados
page,
acá
the first thing.
especialmente al señor David Howard. Él es el vicepresidente de ingeniero líder de la empresa Metrolínea 1. Es ingeniero civil senior y profesor asociado graduado de la Universidad de Hohai en Nanjing, China. Cuenta con una amplia trayectoria profesional, habiendo completado proyectos en China, Myanmar, Macao, Ghana, Reino Unido, Sri Lanka, Canadá y pues ahora Colombia. Ya lleva 3 años acá en nuestro país y ha trabajado en más de 16 megaproyectos. Ha ganado numerosos premios, entre los cuales se destacan la ciudad portuaria de Colombo en Sri Lanka, por el cual ganó el premio INR al mejor proyecto portuario y aeroportuario en el 2020. El Yangshan International Container Terminal Phase 3 en Shenzhen, China, por el cual ganó el Shang Tianyu Award, perdón por mi mala pronunciación, en el 2006. Y el Yangshan International Container Terminal Phase 2, también en Shenzhen, China, por el cual ganó el Luban Award. Entonces, sin más, los dejo con el señor David Wang. Muchísimas gracias nuevamente. Bienvenido a la Universidad de los Andes. Y esperamos tener muchos más espacios como este para tenerlos a ustedes compartiendo esta gran experiencia.
Thank you. Oh. Okay. Thank you. Thank you, Nelly. Yeah.
I don't know if that's enough.
That is enough, or I think that's for the online.
Yes. But I think that's enough.
That's enough.
I will check. And
Okay.
I'll let you.
All right.
¿Es necesario? It's not necessary.
Okay, so I have to. Okay. Okay, good afternoon, everyone. So it's very honor and the pressure for me is to have this opportunity to talk about something, the new technologies. Before we get into the topic, I would say I have a very close connection with this university. Okay, so I cannot hear and okay. Yeah, I'll hold it. Hold it. Hold it. All right. Yeah. Okay. Okay, so it's better. I came to this country in 2019, at the end of 2019. And the first, my team member I interviewed was graduated from this university. And lately, I got more and more my colleagues. Hello? Okay, can you hear me in the last rows? Okay, thanks. Okay, let's continue. So at the moment, I have a big team about design, management, about 30, 34, 35 colleagues. We have many of them graduated from this university. Some of them are at my age. So I'm really happy to be here because it used to be one of my dreams, because I have visited this university. Today is the 3rd time. I'm very, very impressive on my each visit. Your professors, students was really, really friendly and open to discuss and like to know in the studies. So as a newcomer to this country, to the city, I really like to share my experiences with you. So that's why thank you for my colleague and Nelly and to arrange this I would say the discussion. Okay, nothing to do. I'm not going to have like call this like a class. So I just want to share my understanding and experiences in the next 1 hour, right? Okay. So today we're going to talk about the BIM. So I know you may heard about this wording. So we know what's the BIM. The BIM, what is BIM? Who, somebody give me a quick answer? What? Yeah, the BIM information, the building information modeling. So, but the second question is BIM, which one is the core or for this? Which one? You know, BIM, which one is the core of this technology? Everybody knows? Anybody knows? Well, we have a gift. Anybody want to try? Yes, that's right. So, okay, you get a award. Okay, we're gonna continue this question and okay, what's we got? Yeah. Yes, it's information. Because it's not a building, it's not a modeling, it's the information. Because we have to make the information flow and doing the checking, review the information. So the core is the information, don't forget. Because traditionally, when I was graduated from my university back in 1996, so I was drafting by a pencil, by a big board we call number 0, the board, to suit the largest, the paper, okay? So at that moment when I graduated, I was starting use the AutoCAD 14. So at that moment we just got a lot of computer 8 designs, we call it CAD. So that was 27 years ago. So now you can see how much we developed. Gradually, we got a more CAD versions developed. We got a 3D on top of the 2D. And up to now, we got a like 3D modeling, but it's not the case. The 3D modeling, just the tool, make sure the information gotta be checked, gonna be exactly built, checked, and going to the next stage. So that's why the BIM technology is not like we knew just to do just the drafting. So we have to be clarified at the beginning. So because the first time I start with the BIM was about 10, 11 years ago in Canada. So when I was working in the oil and gas engineering company, the first time I learned from the BIM technology, because that moment my company was a mid-class, about 600 engineers. They're working in different disciplines and the piping process and mechanical, civil, structurals, and what else? So all the 600 engineers work together every day. So how to make sure the design information be exchanging on the real time? You make changes, I know right after. So that's the BIM starting. So every night, every day, I receive a few emails from other discipline saying, hey, I changed here, I changed there. I put a color on this member, I need support on this pipe. I need support, I need a skid, the foundations for this equipment. So based on that information I got it, I have to make the changes every day. And after work, maybe at midnight, the IT team come to the office because nobody work at that moment. The IT come up with all the latest BIM models, individual BIM model by different disciplines, and they do the federation and the phrase, and then named with the date. So tomorrow, when I come back to work, we'll get the latest federated model with all the information collaborated, or we can find clashes, new clashes. Just in case, we put it on the separate in the folder, just in case we want to check. If somebody change their mind, so sorry, sir, I don't want this change. I want to go back. Okay, I got the model on the date. We come back, we know what's the model for the yesterday. We change back. So I think that's the beginning. Because it's 11 years ago. So now the technology is improved. It's not by manual, by information, by email. It's automatically, you get a notice and you're gonna mark up on your model. So that's why that's the reason why I want to share the experiences with BIM technology applied to the Metro Bogota at the moment in the design stage. Yeah, by the way, if you have any questions, you can raise your hand and anytime we can talk. So our topic is BIM in the design phases of the city railway project. So here's two keywords. One is the BIM. The other one is this railway project. So why I limit this topic as this? Because BIM is like widely used technologies at the moment. Why I have to put the railway project? Anybody know? Okay, so the railway project is quite complicated. We have like more than 50 disciplines in design working together. Even more than the oil and gas, right? And also is quite important or quite, they have really, really high standards because the railway is taking the passenger. The safety is the top priority. Okay, what's wrong with this? All right. Okay, so we have a really high safety consideration standard and the more like precise requirements to all the disciplines. They have to work together, right? The civil, the truck, the train, the signaling controls must be work without any delays in between. Without any mistake, the system gonna make. Okay, let's start. Yeah, that's me. Okay, I don't want to. Okay. Okay, we're gonna have 5-6 sessions and for the project information and events, and right. Okay, and general information, collaborative in design, execution progress, and. Okay, the project, I would say, I believe you guys all know this, quite familiar with this alignment of the Metro Bogota. This is a first line. So we're gonna start from the depot. We going through the 16 metro stations. In that we have, from here, we got 13 BRT stations. Some of them are exchanging with the metro stations. The total length is about 24 kilometers. The line is 100% elevated. We call the viaduct. We have more detail in the next slides. Okay, here's a video. I don't know if we can provide a video. Okay, this in You can read it and subtitle. Okay, this was made in Chinese. Okay. Okay, that's the depot. We have 16 stations. We have inside the contract 2019. That's the joint venture of Metro Line 1. This is a control center. Yeah. This is a ceremony of signing. This is existing city. Well, it's not Bogota. I think that's somewhere else. Yeah. There's our designer. Yeah. WSP, there's a Chinese designer for the system. And we have Alstom, who is responsible for the signaling, the train control. This CRRC is about the rolling stock fabricator. Yeah. So you can see the map of all the resources we mobilized from the global. So this is the quick sketch for the development of the BIM. This organization, we will do this. We'll give you more detail about these organizations for the designs. Yeah, that's all the BIM team. Yeah. This is a quick presentation about the BIM progress. And all right, so we can. All right, can we put the sound? Yeah. Yeah. That's a short video. All made by BIM. Okay. That's a station for 68th Avenue. Huh?
Development design and the collaborative design are achieved with.
It's okay. Can you hear and back? Raise the sound. This guy also graduated from university.
Traditional design, design workflow, and modern simplification are established in the economy, so that a universal unified principle could be adopted within all the design stakeholders. Existing as a compliance system, the next project incorporates mainly the civil and metro system parts. The first metro line program incorporates 9 design elements. 33 systems, 270 subsystems, and 597 execution units. Taking into account the range or discipline and the scope of the project, multiple BIM tools are adopted for the convenience development of each discipline. For example, Bentley is used for well-track design. Autodesk 3D is used for those municipalities. Revit is used for architectural and any the survey and existing data is in GIS format. RGS is frequently used in this. This slide, we understand the criticality and importance of the design workflow, and optimization of the design workflow is achieved with the help of BIM and the CDE. More specifically, the information exchange workflow is established based on the modeling sequences, coordination plan, interface segmentation, and the error file from the downstream stakeholders. The frequency and the method of information exchange shall be clearly defined. A daily basis information exchange has been achieved within the project, hence warranting the necessary information exchanges between various disciplines. The extent of the collaboration lies in the data drawn across different disciplines. The data collaborations between different design software is quite flexible, which is based on the information, frequency, and the data exchange method, such as cloud-based collaboration data, templates, schedule, share parameter table, and the share panel. The cloud-based configuration is always preferred if possible. Take Revit, for example. The collaboration cloud we achieved via WordStat, Link and Link Cloud Collaborate Pro. The Link Cloud Collaborate Pro is similar to the WordStat, except that the central part is storage in the cloud. The above mentioned quantities are smooth collaboration across different time zones. Meanwhile, for the warranty, the design collaboration by the controller, the delivery emphasized that the design modes are the major part of the design delivery. The two drawings will only be extracted once the corresponding modes are approved first.
It's a feature of the depot. Okay. So you got some ideas. Okay, so this one, we want, this part, I want to like update you about the progress for this project. This area, I believe you guys visited a few days ago, this the depot, which is far from here. And now we finish, at the early of March, we finish all the ground treatment with the CMC. So at the moment, I think is quite good in the ground treatment. We have the monitoring quite stable. Next one, we're showing the building on top. We're starting, well, this another video. We're starting the warehouse for the precasting yard for the piles. We're going to use the precasted concrete cylinder pile, which is pre-tension, and we have like pushing machines with the hydraulic hydro power. So this you will see them later this year on the city. So they are responsible for the piling, foundations, for the stations and the well duct. So is under preparation. I think this the quick way to. So when you was there, it's built? When you visited, it's built? Okay. 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 All right. So this kind of a pile has been used in one project, Cartagena Bridges. Yeah. This is the second time we apply this kind of a product in the city. So, and also this is the first like plant fabrication line imported from China. So to produce these kind of piles. I believe maybe in 4 months, you can have another visit to see how the piles production's running. Yeah. So, and the piling could be seen next to the depot. We're starting from there. Okay. This is another new area we started, the AB68. Everybody knows there's bridges, existing bridge. One bridge. At the moment, we have done the first pile, 2-meter diameters, 60 meters long. It's 4 piles, pre-activated, was done 2 weeks ago. That's for the foundation for the new bridge. We're gonna build 2 bridges to replace the existing bridge. Because we're gonna put the well duct in the middle of the 2 new bridges that the metro going through, and we have the station as well at this location. All right, so now we come to the main part of the BIM. The general information I will talk about some basic or fundamental information about the BIM. Maybe you know, so okay, what's the BIM like we discussed. It is the building information modeling. So was starting. So we have some no BIM stage and come to the BIM stage. And we have the database and API and CAD BIM. We have a different 1D, 3D, 2D, 3D, and up to 7Ds. Or explain a little bit more. So this the map of the history of development of the BIM since 1970. Gradually, you can see the map. So we go from 1970 up to 2000. We have the different developments from. I think the body is CAD, and gradually we go different method. We go to BIM, and so that's just a brief of the history. Okay, that's the sketch you just saw in the video. So we have a different levels. I believe usually we got a 3D for the design here, and laterly we gonna like building into the BIM concept, and we have integrated in the level 3, information, building information. So integration, also 3D for the design here, and laterly for this construction procurement, we're gonna go further, use the design information to get a time schedule, and the quantity and the cost, and the final one would be the performance. I think it's for the project management. You see, there's lot of list items listed. I don't want to take more time on this. So this is the project information. So like I said, why we put the railway project here is I want to show you that the complicated. So the superstructure, so the viaduct, 24 kilometers, and the speed is 80, but operation speed is 42. We have a GL4. GL4 means no driver. Okay, everything normal operation. You don't see any drivers on the train. So everything is controlled by the signaling and the supervision control system. So that means we won't get any manual operation. So for accident, they have to have like automatic reactions in the system. They have to identify the risk, the hazard in advance. So they have a lot of system we call the RAMS system that I had this introduction speech in another university in last year. So we have the RAMS system to guarantee the reliabilities for all the system working together. So this is the most complicated part for this slide. And we, as the others are just the basic information for us. We are a concessionaire for this project. We're responsible for design, construction, and procurement, testing, commissioning. And after that, we'll get 20 years operation and maintenance for this line. So another thing I want to show you is about here. We have like 9 design sub-projects, 33 system disciplines, and 250 subsystems. So that means something we can see like civil structures, right? We can design for it, but like a systems, control systems, signaling, monitoring, and the supervision system is kind of unseen. So have to design by the program, by the devices. So we have to. That's why we have to do the testing, commissioning to try to. We have the simulations for this kind of system. We have the train like simulation to all the speed in the computer program. And this is the contractual requirement the BIM uses. The BIM uses is come from the design. I don't know whether you can see this. This is a bit light. This is a planning stage, design stage, construction stage, and operation stage. You will see, maybe you couldn't see it, it's quite small. So you can see the BIM requirement application would be from the very beginning. So we have to plan for the BIM structures, organizations, and the executions for the design, construction, and operation. So it doesn't like some kind of a BIM users. We just use BIM to do the 3D, right, and hand over to construction for their information. But this project, we have to fully use the BIM technology. That means at the planning stage and design stages, we must talk to the operator, because we have to know what kind of information. Don't forget that information is the core of the BIM technology. So what kind of information the operator is needed for the final operation? So we have to build the model from the beginning with this information. That means give the room for this information for future inserts, no matter it's in later design, construction, and procurement. So that way we have to plan from the very beginning with a clear demand from the end users, that's the operator. Because the operator gonna be doing their job with the information from the design, construction, procurement, all the equipment. For example, the equipment should get the information of the brand, manufacturers, and spare part, how often to do the maintenance. This kind of information has to attach to the BIM, to this equipment. When you click on this equipment, all the information pumped up, and you will know where to find this part, where the menu, operation or repair the menu. So we can easily find the information from the database. That's the use for the information transferring from the design to the end. All right, so this is the requirement for the project application. So we have this kind of a flow chart for the design, the collaboration crossing various disciplines based on the BIM, because that means we have to create the space for all the disciplines work, right? The civil guys bring the structure or the civil works, and the system guys bring their devices. So they will do like build the Lego together. Okay, so we have this kind of a chart to see the design, we call it the design and the plan stage and different stages. But this is a cycle. So we're doing like the construction, like the conceptual design, the 30%, the preliminary design, and 60% the detailed design, 90%. So now we're at this stage, 90% to 100% stage. Now after this, we handed over the design model to the construction team. They're going to do a further development with more information attached to the model, with the design, with the construction quality of inspections and some defect repaired and the design changes as well. So finally, we give the design, the construction BIM model to the operator. So in this procedure would be like a revolution of the BIM model, because from the design to construction, we have a really, the more information attached to the model, the model get a really big, heavy in the data. So when we hand it over to the operator, they don't need that, right? They don't need that. So we have to do some lightening works. We're doing some changes on the construction, final construction model to put all the data together into the database and to give the light model, BIM model to the operator. But we have to build a logic link to the database. So when they click on that they will get the information from the database, not directly from the model itself. Right, here's the BIM organization. So the BIM is not for one team, is for different parties, different roles for the project. So we have the concessionaire here as A, was centralized with us, and the leading designers here in the different disciplines. And the C is the contractor, is the design contractor, it's a team, design team. The project team is here overseeing. We have the delivery team to assist the design team to deliver the final result or the final deliverables. So we have this table, just give an example with responsibility matrix. We have separate packages, disciplines, packages, deliverables. Here we have different parties. So we defined the responsibilities, whether it's accountable or responsible or support or review or provide information. Okay, here's the exacted organization of our design team. You will see we have, we just look at it here, okay, and here we have the interpreter and our client. So the design teams in charge of the whole BIM team. So the designer, we have the design contractor, the design. I would say you may know we have in Colombia we don't have too much like a railway system engineer or some experienced resources. So that's why we got WP's UK and Canada join us. So they're responsible for the systems by UK, and Canada is responsible for the superstructure, like we call the UBIM. And systems, we got this UCD is from China. They are doing the detailed design continuously with WSP UK. And Alstom, no doubt, they're good for the signaling. And the CRRC also one of the biggest fabricator in the world for the rolling stock. So you will see we have every team. They have the BIM managers. They have the coordinators, managers here, and the coordinators here. Every team they have their own BIM teams. So at the end, they report to ML1s, BIM managers, and also the BIM coordinator, whatever. So that means this more than six teams working together. And the challenge is here. Normally, we gotta design in one country, right? All the teams in the same area. And even they're in different city, but they're in the same area. We'll have the same time zones. But in our case, is almost impossible. Okay, we have Canada, China, and China again. So that means several teams working 24 hours. So how to make sure that the information are collaborated it's a big challenge for us. Yeah, that's what I just said. We have a lot of challenges, coordination, communication, because sometimes we speak a different language, right? Different designers, and technical, because every company, they have a different kind of I mean, how to say that? For example, the software. Okay? We have Canada, we have Colombia, we have UK. They use different software to build. For example, we use Revit, but WSP UK, they said no, I want to use Bentley. So there's also a challenge. It takes us a long time to do this converting, how to merge all the like models together. Because for example, in Colombia, we have done the model, we go home, and at the moment, the Canada UK team started working. So they're working the model you have finished. So when you're finished, they update it. So this is not on the same time zone. So it's a problem. So that means the delivery challenge, the same thing. So everybody deliver every company have different like their standards for the deliveries. We have to make the uniform only one standard for delivery in the BIM. So we have to like talk to each team to make sure they are agreed on the same principle, protocols in communication and the deliveries. So this is the challenge from the BIM for the project. So we at the moment we totally we have a 1,700 models for this project. Total documents for the design report and the drawings is I think it's more than 25,000. So at the moment we're at 90% designs. So that means it's starting from zero after 27 months. Now it's about 30 months. Gradually we come up with the full package for design deliverables. So that's the huge, I think this is a huge amount of the designs. So that's why we have to make sure all the different design reports match together and without any like a conflict. It's not easy, okay? Okay, then I would talk about the collaborative in designs. How did we do? Okay, this is the standard. First of all, we have to agree on the standard of the implementations. So that's the standards we shared, we request to every single designers. So they work, we must work on the same standards to make sure we got the same qualities of the product. Yeah. All right. Okay. Here's the BIM roadmap. So we got a different. We put the BIM uses in the actual, and also the LOD downstairs. We start from 100 up to the finish of design. The BIM level should be reached 350, and after that, construction reach the 500 and 500 at the end. So LOD 500 is well known, but practically is difficult. Okay, that's our target. You know, we have to keep our target and see how much we got it, but this must be. This is a short video, so I believe you already saw that in that video, but I want to get the large one, so we will see what the list of the disciplines. We had a civil, rail, truck, elevated, superstructures, and the power supply, communication, signaling, integration, monitoring, structural, and the roads, landscaping. So this allow the infrastructures, and the BRT station and the network locations. That's all the discipline has to be done. The design has to be done in BIM. And the software here we list is now we're using. So I don't know if we can see that again. Yeah, this is the metro station. We took one metro station as an example. Yeah, this is the truck system. This is the whole elevated well duct. The well duct is, we designed the segment. We're lifting up and put them together. It's a topographic. So the road system, the architectural design, yeah, structural, all the MEP. Yeah, this is a video to show how the BIM growing. All right. So this all from the real design, not like a video, so, right? So yes. So to get this one work, we have to like talk, get a communication between discipline to discipline. Yeah. For example, we call the gauge or the space for the beam for the rolling stock running. So we have to talk with the truck discipline. We have to get a truck discipline and the rolling stock itself to make sure the train running on the different speed, not hitting the edge of the structure. So this thing is easy, but it quite complicated. We have to do the simulation for the car running with under different speeds to see whether they're on the curve that the train gonna be a little bit climb. So maybe the train's not gonna hit the edge of the structure. So make sure we can leave the gap there. And also the top flange for the superstructure is for the evacuation. We have this wide. If some breakdown for the train, everybody should get out and run and walk on the side, both sides of the beam. We have the lighting system for the evacuation and the night. Also, we have many attachments to the structure at both sides for the signaling, for the camera, for the supervision, for the radio systems. So this is quite complicated when you design the beam, the U-beam we call. So you have to consider the whole disciplines on it. The track, we have the four rails, and the crossing, because sometimes the train gonna change to another track for some reason. We'll break down, we'll repair, or emergency stop. And also we have to take care of the passengers, right? And to avoid, we have the signaling system to avoid any clashes or collisions, right? To avoid the derail. I mean, the derail when we will run very faster, the train will be like jumped over from the rail. So we have to consider everything. Yeah, but maybe finally it looks okay. The train is running, everything is good. But when you're doing the design, you have to consider everything. Even 1 millimeters, we have to discuss. All right, so that's the beam execution plan. That's quite important documentations during the planning of the beam. We have the BEP, we normally call the beam, BEP is beam execution plan, and the TIDP is a task information delivery plan, and MPDT is the modeling, is the model production and the delivery table. That means that we break it down all the works for the design deliverables. We put a model accommodates the design breakdown. So all this document is have to be ready during the planning stage. All right, so that's also the part that quite important content for the beam execution plans. So we have like 6 parts. So and also how many annex. So to complete all the informations that should be asked by all the parties. So that's the contents of the execution plan. All right, so this is quite important for the beam delivery workflow. Maybe it's too small, so we can share this one after this presentation. This we have to go through the beam development stage and the beam coordination stage, and this one I couldn't see it. Yeah, this for the shared. So for review for the different discipline review, and this beam model review, and then after that submit. And we have the different parts to do it. So that means is when from the beginning, from the creating of the beam model to the delivery, we have to go through these procedures by all the party related involved. So that in this case is daily communication, and we will have the model review in between. So to make sure all the discipline clear and they modify, accommodate the request from other disciplines. So you can see this information is quite important. It's the model, not the model itself. All right, so it's a common, we call the CDE, the common data element. The CDE is quite important. This is kind of that data, how to say that? It's like a brain. So all the information going to be exchanges in the CDE system. So we have built our own CDE system after a deep investigation in this country and talk with all the designers and let a grade at the end. All right, so finally, we got an Acronex. This is for the delivery platform required by our clients, and we got our document control systems, and this the design department, and we're dealing with the submission, internal submission. But for the designers, you can see the designer list here. And WSP as the we call the design contractor. He's the general designers responsible for all the review and integration interfaces management. So we treat them as the design part. So they will have the communication through like SharePoint and the team and the BIM 360. Now BIM 360 is becoming another name. Okay. So what's the use? So on the SharePoint, we have the different flow chart workflow for review in between these designs. For example, I got a design done, I put on the SharePoint, I initiate a workflow. So that means everybody got a message to review this one by the time. So by that time, we counted the date. If by the date, for example, 5 days, and 3 days you have no response, we're gonna send you a warning. So please review and get the comments back. So when this workflow done, we know all the designers had to review it. And the comments, if there's no comments, we're going through to our department. We check after check, we send it out. And that's the document. What's the use for the team? The team is for the real-time communication. We create a lot of groups in the team. So that means a structural design group, architectural design group, different system design groups. So we bring all the designers, engineers, leads in this group. So they could communicate to each other, no matter in UK, in China, in where. So they can leave the message here at the person you want to get an answer. So you can quickly get an answer, not waiting for the 6 hours, for the 12 hours to make a call and to get an answer, or send an email and to get a response. So that's the use for real-time communication to get an answer quickly. And the BIM 360 is like the storage of all the deliverables for the final submissions. So that's the brief of our CDE. Now work, I would say, pretty well. Okay, that's the design, collaborative design workflow. So we would say this kind of a collaborative flow is centralized with the CDE as well. So we got different disciplines, models here, and we put like a truck and with the multiple municipal models, and they're gonna link to what's called the structural models together, architectural models, and finally we're gonna go review by the M&E, that's the mechanical and equipment. So finally we have all the like information or comments sent to CDE, and finally we got a federated model fixed for delivery. Okay. there's another one. So we got a WIP, the work in progress folder, with every single designers. So they are credited that work in progress models, but they saved in there. They give the access to us, and so we can have a look. What's the model progress? And the problem in there are all the disciplines, relative disciplines could get access to see whether they need to send requests or questions. Okay, so I won't take much time. I think this is quite long. This is the BIM model software matrix, which we have different kind of software for different disciplines. We'll call that. Yeah. So with like a Tekla for the structural details, Autodesk Inventor for the architectural or the topographic, for the truck, and Bentley for the truck. Autodesk Civil 3D for the civils and Revit and ArcGIS and design builders and whatever. So you can see this. The BIM is not limited to one software or another. So the BIM is the system to transfer the information. Okay, this is standardization of the data template. So we have the dictionary for all the templates of the data. So we have this as registers, registry for all the data format. So all kind of the data online is more than is a more friendly way and replacing in Excel basis. So we can get more details if you are interested. This is the BIM design management. The first of all is a collaboration. So we make the workflow for the design plan, scope changes, interfaces, system integrations, BEP, and the risk management. All these has to be considered in the BIM modeling and the collaborations. So all this software is quite important to support the collaborations. We have this one, Relatix, is for the interface management. And this one, I think I already introduced. The BIM 360 now is becoming, we call ACC, is Automatic Construction Cloud. This one replaced the BIM 360 at the moment. Yeah. And BIM track is also the tools for the track the changes on the BIM. So with this software, we're able to make sure the collaboration is done. Okay. The BIM model technologies management is, that means from the work in progress, we're going to go through the change control with the information requested from the reviewer, checker, and another disciplines. After that, we're gonna, in 360, the checker identify with the drawing model contains the changes in the element should be active. So the change control team come up and validate the information and the impact of the change. And if it's approved, we're going to another process to change the control team to validate and the major quantity of the element should be compiled without affected project development. Finally, the model changed, the drawing changed. We have the element updated, and the baseline is updated. So the baseline is quite important. For example, we have a lot of elements for the systems. For example, this cameras attached to the ceiling. So that means the architect has to be phrased. Yeah. So in this case, we must push the architect design as early as possible to consider all the requirement from the other discipline. For example, they have to give me the location of the camera on the ceiling, so the architect could consider this, and also the space of this classroom, right? They have to define. But if the safety guys come and say, hey, this is not enough for the evacuation from the emergency, they have to change. In the other case about the equipment, we put like generators or other shifting combines in the room for the system. So they have to know how big is the system, is the equipment, how heavy is the equipment. So that's why the baseline is quite important, because if we couldn't phrase the baseline, laterly the baseline changes, everything, all the discipline gonna be changed, review and change again. Okay, so this the technology started management. We use a different color code to show the status of the model. Oh, sorry. Oops. To show the status of model, what's in this status, right? So it's in the identifier or in developing, coordination, frozen, references, and the delivery review, and the 2D extraction. So that's quite useful. It's easy to identify what's the model, where the procedures and the model are. The interface management, I said, is like a secondary functions we used for the BIM, because the BIM we have a lot of, I don't know how many, it's 1,000 of, I think it's more than 1,000 interfaces between discipline to one another. So lately, it's quite hard to identify the interfaces from drawing to drawing, model to model. So lately, we tried best to use the BIM model, identify to mark up the interface from one discipline to the other. When the interface closed, so we changed the color back to normal. So that's easier for the designer reviewer to know when they review the model. Have this interface, a different color, we got an interface open. So we have to send a question to two disciplines. What are you going to do? Okay. So this also another change interface management software. I believe that is the one realistic. Okay, that's the delivery management. We have delivery list, like the normal design procedure. Before the design, we have to make up the delivery list for different design stages, and we follow the list with the time. So we get a delivery list and we put in the model. We have the 2D drawings, schedules, database, and the technical report, and this one, progress data. So for the BIM, the final delivery format is IFC 2x3. It's not, we have to do something after the model produced from the Revit, and also this is a native BIM. Okay, this is quality control. It's quite important. We have to check the quality ROD and ROI, the level of information, and the ROG, the level of geographic. Yeah. So that means we have to ask the designers to go through all these checkings, self-inspections, validations, class detections, and the parameters, and the standard checking, technical review, standard verifications. All right, so here's, I want to introduce a BIM plus Gs. That's a BIM model with the GIS, the Geologic Information System. That's, yeah, this very faster. Yeah. So we got all the information in the GIS basis. All right. Okay, this is the GIS technology assistant, the linear engineering project like the metro. So we got a GIS like information here. We put our models on. Then we can know what's the surroundings of the models, catch the GIS information. That's a video here showing. So we can catch the more information than just a model alone. Okay. All right, so this part we're gonna introduce the execution progress. At the moment, we're under the procedures from the process from 90% to 100% of the design for the metro. So this is the full map of the metro. We'll see. Yeah. Yeah, for example, that's the station. Yeah. This is the navigation from that's a metro station 3. Right. Yes, you can see within the model, we can find the drawing easily. When we're doing some development now, we want to put a model with G's on the whole line, and we put all the drawing design report linked to every single element. So that's what we're doing now. So to gather the engineer on site who's doing the construction, they want to find the drawing. They don't need to call the office to find the drawings. We give the model and maybe put on the phone or iPad. They can easily click on that. The drawing pop up. They can see it. So this work is under development. So this the total amount of the model breakdown. So you can see we have 200 more than 1,200 models. That's a breakdown for the disciplines. So we got the viaduct, main corridor, and special intersections, and metro station, BRT, depot, system, equipment, and others. So we got all the list for disciplines and the breakdown, the model breakdown. So all this breakdown is matching the 2D drawings and the report we normally call the deliverable list. Okay, that's the general progress we made now. You can see most of them are almost 100%. Some of them are 90 or almost 90. So metro station a little bit behind because it is not mean design. Metro station is quite a complicated building. We have to take care of the train, take care of the passengers, take care of all the system, the control system, like the door, and the entrance, the access, the ticketing, the power supplies, all the MEPs. It's a quite a complicated building. I believe is more complicated than the residential. So that's why we put this one a little bit late to the next stage. Okay, so this about the progress. I would run a little bit faster. This is the standard we're using for this project, and the BIM team is focused on those standards when they're checking or review the BIM teams, the BIM models. Okay, so this is the main focus on the BIM management. We'll have to check the inputs. We have to check the input. Sorry, check the inputs like the technical requirement, BIM execution plan, and some specifications. And the next one is the design progress. We have to check the model and the coordinations, make sure the model is appropriately created between the engineer and the modelers. And next one about the quality assurance, we have to go to the quality QA/QC check procedures, which is could be automatically come up from the software itself. And the last one is the output. So here I have a example for the model review. I pulled out one BRT station we call MEP disciplines. We have this kind of a checklist with all the status of the checking. Where is it open? Where is it closed? All the discipline list here, and the checking list items here. And above is the transmittal number. So when we want to know what's the status of the model, we could easily find out what's the status. So which columns is open. We can find out the reason and the push to complete. All right, this is the information definition and the management. So we have to check like civil. We divided in the civil engineer. We have all this one to be checked. The pavement, urbanism, landscaping, structural, and others in the geometric, architectural, and the geotechnical. And MEP, we have a different disciplines. So all the information has to be going through. So this one, I will talk about the ROD and ROI and ROG. So this is quite critical. The ROI is level of information. We have to define the per discipline. So which discipline we need in which information to be attached to the design model. This is not like a single party's job. We have to confirm. We have proposed, but we have to confirm with all the disciplines. They agree with this kind of information with the ROD 350 at the end of for the 100% designs. It took us about how many months? Almost 1 year to get a reach agreement with all the designers. Okay, this is information delivery planning. So we have like resources to be prepared in the lead, the appointed party in the execution stage. Yeah, including following the execution plan and the detailed responsibility matrix and the master information delivery plan. So all this is the guideline for everybody's actions. So this is the information delivery planning. So we have all the registered. I don't want to go deeper, but it's quite useful for checking and review the progress. And also the open data we have. We use that building smart, like open beam concept. Now, actually, the first video we prepared is for building smart. I think awards, but unfortunately we didn't get it last year. We'll try one more time this year. Okay. Okay, this the clash and the design issues. We put this like a color, different colors to identify the clashes. When we check the model, and also we requested the designer to come up with the class report when they deliver the model with us. Okay, this the little bit planning. So we are going to make some guideline for the BIM during the execution of this project. We learn a lot. We got more practices. I think by the end of this year, we're gonna make this one published. Okay, so the next part.
You have to cut it short because there's
Okay.
another class here.
Okay.
at 5.
Okay,
But if you want to.
5 minutes?
close, Yes.
Fine. Okay, so sorry about that. So, yeah, so for the next phases, we're going to into the construction phases. Now is the planning. We will build another system like a smart platform for the construction. The BIM technology also is quite an incentive. This kind of technologies with a camera on the helmet to detect the progress and the scanning the progress. So this information could be transferred, sent to the center, to the data center to monitor, to get up the real progress. I have to move faster, okay? This is a construction application. The production, storage, the transportation, installation, so all this information has to be collected on site and stored in the data center. We put it like built twice. That means we have to build physically on site, but we have the like a simulation or the real time models in the BIM. So this also another task time locations progress. I have to this for the operational stage. We're gonna have the new platform with BIM combined with another operation platform. So we'll get them to manage an asset, all the information of the repair of the machines. All right, so that's all. Sorry about that. This is quite long. Yeah, thank you so much.
Personally, felt very, very happy when you showed us that video.
It's quite short because for very lot. But
We always see the walkthroughs
Yeah.
of your renders.
Yeah.
And we could tell that it wasn't a render.
it's not a
it
render,
was-
guys. Yeah,
So I really appreciated that. And
thank you.
Thank you so much for sharing it so openly. with us.
Yeah. Yeah, no
So,
problem.
thank you very
Anytime,
much.
anytime. Maybe we can come later, come next few months. We got more to present.
Thank you
Yeah,
very much.
yeah. Anything?
Again, so sorry.
No, sorry, that's my, I have to, okay. Okay, no problem. So I would say, Yeah. you have questions?
Some questions,
Oh,
maybe if we can get them.
yeah, send to Ines so we can answer later. And also I think you're welcome to,
Very interesting.
okay, thank you so much.
Connected with.
Next time you can go to my office, we get a more detail.